Hello. So in this project, we're going to be doing part 2 of the Kubernetes project, which is to prepare for Kubernetes deployment. And so we're going to set up a Kubernetes deployment. Okay, this to prepare the app's backend for deployment with Kubernetes. This is part 2 of the Kubernetes with AWS series. We've learned how to launch the Kubernetes cluster in the previous project. Now we're going to take the entire application backend from a team member that's in their GitHub repository, and we're going to pull the apps backend from GitHub and prepare it for deployment with Kubernetes. All right. So basically, these are the steps. We're going to create. Go to the IAM role. We're going to create an EC2 instance. Give it the IAM, the permissions. Use the cluster to create the Elastic Kubernetes. Then we're going to go into GitHub. This part 2. Yeah. GitHub, we pull it into a Docker image and then into ECR, Elastic Clusters. No, I've forgotten what ECR is. I'll figure it out eventually. But yeah, and then we're pulling everything into the Kubernetes service. So we're going to do some guidance because this is full of code, and again, I don't know enough code to be able to handle this myself. So we're just going to start first, and we're going to set up an EC2 and then the EKS. So first, let's launch an instance. We'll call the instance this Nextwork EKS instance. We're going to make sure everything is free. And then no, we'll leave everything else as it is, and we'll launch the instance. I have to give it time. Let's view it. Cool. Now we're going to connect to our instance. Connect. Awesome. So we're going to take this. And we're going to install the Elastic the eksctl. What is that called? I've forgotten what that is called. Let's see. Okay, that has been created. So the eksctl is a command line tool for working with Amazon EKS, and we're using EKS CTL because it's the simplest way to create Amazon EKS clusters. All right, so now we're going to create our IAM role and attach it. So we'll just click here and then open link to new tab. Close this. We're going to go to roles. We're going to create a new role. We're going to call it wait, hold up. We'll attach the EC2, sorry, and then we're going to give it admin access. And we're doing the admin access again because we don't know exactly all the permissions that we'll need for this service, and so this should help. And yeah, and this grants permission. Oh, I didn't write it down. I don't remember it either. Let's see. No. Let me see if I can remember it. Grants EC2 permissions. Let's see, admin access permissions. Next work project. Okay, I don't remember exactly what the description was that we used previously, but this should give the gist, and then we'll just create the role. Creating AKS constructs takes time. Yeah, I see. So instance shard access. Yeah, cool. Before we can do this, we need to be able to give the instance access. So we're going to go to security, modify IAM rule, and then we're going to give it the EKS instance role and update it. Then from there we come here, oops, nope. We attach everything and we put our code, AF South 1, that's our region, Cape Town, AF South 1, and hit enter. And now while this is creating, next we're going to, so creating is going to take some time, around 10 to 15 minutes. In the meantime, what we're going to do is create another EC2 instance so that we can do something else. So, and actually you're allowed to create, you can do, you can connect multiple times. That just means multiple sessions. So while this is, working in the background, we can use this for the rest of our data. That's all we need. So yes, we can run to, just talk about here. You can run open multiple SSH sessions to the same EC2 instance. To multitask or monitor logs while running commands. Next. Okay. So next we're going to go to our team members GitHub repository, which is here. This is the GitHub's members repository. Is it? I think this is the repository. Oh, no. Let's go back. Okay, I'll just come back here and click this and close this. Oops. No, that's not it. It's not here. Let's close this. Okay, it's here. So click on code, and then here is where we're gonna get the URL. I'm gonna put the URL in here, and we'll basically just do git clone, and then I'll put the URL we took. Yes, we can't find because we've not installed Git, so we need to install Git. I'll do sudo dnf update then sudo dnf install git y. Oh, so it only did the update, it didn't do the other one. That's too bad. I thought it did that one too. Okay, so let's just do it from here. So did do enough install git y. Perfect. Oof, now we're going to configure Git. gonna put my email here. David@gmail.com. Oh. Da, 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 da. Okay, I'm gonna hit enter. So we've configured it. Next. Oh yeah, now we're going to clone it again. Perfect. Cloning done. So we're just gonna do ls, and that is the folder in the repository. Yeah, I think it's this. Is it? Yeah, this is it. Okay, cool. So we've cloned the repository. Now we're going to build a container image for the backend. Basically, we need the containerized image so that we can deploy the backend code. So here we are, we've taken the GitHub stuff. Now we're going to deploy that. Okay, cool. Where is the code? The code should be here. Oh, this is it. So we're going to see a couple of errors, 4 installation errors. So let's prepare for that. Docker not it's not found because you've not installed Docker, so we need to install Docker, right? Docker isn't installed, so we need to install Docker. Okay, so we'll do sudo yum install -y docker. And another error. Okay, oh, no error. So Docker is installed now. And then now we're gonna try to start Docker once this is done. Sudo service docker start. And wait for it. Perfect. Sudo service docker start. Perfect. We've been redirected to this bin. So we're going to run the command to build this again. It still should give us another error because we don't have sudo there. Basically, we are using permissions from the EC2 user. Let's do who am I. Yeah, we're using EC2 user permissions instead of using like admin permissions. So we're going to have to add EC2 user to the Docker admin. So let's see. Yeah, that's it. So when I launch the EC2 instance, AMIs, okay, so AMI is like Amazon Linux. Default user for SSH is EC2 user. This user comes preset with the AMI. Okay, so we are logged into the this SSH session as EC2 user. Cool. Yeah, we did that. So now we're going to add EC2 user to the Docker group. Listen, sudo user modification. It's a-g docker EC2 user. Cool. So now we're going to run it again, and so it adds EC2 user to the Docker group. Perfect. Oh, so we need to first restart this so that the update will take effect, and then we're gonna build this time, right? Wait, let's see. Oh, first we have to make sure. Let's make sure first. Yes. So EC2 ADM wheel system D general Docker. If you see Docker listed, then EC2 is in the Docker group. You can run Docker commands without adding sudo. Perfect. This is for build. Nice. Just we failed again. Yeah, we failed. Another error. Because our terminal needs a Docker file to build a container image, but I can't find the right one. So we're gonna have to change directory to next work. Perfect. Flask backend. Enter. We're in. Nice. The terminal should show all the files inside Docker. Okay, so if we do ls again, yeah, it shows everything. So the Docker, okay, cool. So the Docker file is here now. So now if we do the build, it should work. Perfect. So we just took care of all the 4 errors. Now we're going to push the container image to Amazon ECR. Oof. We're going to have to create a new Amazon ECR repository. Elastic Container Registry. That was what it was called. We're going to take this. It's going to be too much to type everything, but okay. In the meantime, why are we using Docker and ECR? We're using Docker to wrap the backend code, its libraries and settings into a single container image so the app runs the same everywhere. Okay. Then Amazon ECR is a secure cloud repository that stores the images. We push the image once and the Kubernetes goes to launch the app. It simply pulls the image from ECR. When it goes to launch app, pulls the influence. This workflow gives engineering teams consistency across different members, wiping out the it works on my machine problem. Okay, cool. Alright. Now I'm gonna type this code. Enter. We got it. So the process from writing code to deploying an app. So the coworker writes the code, they give it to me, or they push it to GitHub. Then I clone the GitHub repository. I build a container image of the app provided with Docker file. I push the container image into a repository, that's ECR, and then Kubernetes pulls the image from the ECR to deploy the app, and then it deploys and then the app is deployed. So these are the 3 stages. So coworker to GitHub, I clone the GitHub, and then build a container image provided with Docker file, and then I push it to ECR. So coworker to GitHub, me from GitHub to Docker, then to ECR, then ECR Kubernetes will pull it from ECR and then deploy it. That's it. Okay. Command has been run. What does this terminal response mean? It confirms that Docker repository has been created. It's ready for us to push Docker images. So basically, this explains the answers we are seeing. So repository ARN is the Amazon resource name. the unique ID for the repository, which is this one. This is the ARN, and then the registry URI. This will push and pull container images. What is it? Repository URI. This will push and pull okay, cool. Then there's the repository name. There it is. And then the image mutable. The name given to the repository. Okay, cool. Image tag mutability. Whether the image tags are mutable or immutable. Mutable means we can override which image has the tag. The latest tag can be taken by a newer image at any time. Then there's image scan configuration. Whether the images can be scanned for vulnerabilities when pushed. And encryption configuration. The images are encrypted using this for security. Confirm. Yeah, we can confirm that we can, oh, okay, so we need to go to, where is it, ECR, and confirm that we can see it. And can we? Voila, we can see it. I'm going to view push commands. So we're going to push the container to ECR. Cool. So first we're going to do this one. So we succeeded. So basically this one was supposed to retrieve an authentication token and authenticate our Docker client to the registry and use the CLI. Okay, build the Docker image using the following. So I think we've already built the Docker image. We've already done this, so we'll skip this step. And then we'll go to 3. After the build completes, you have to tag it. Okay, so I have to tag the image so we can push the repository. The tag is basically giving it a name. Right. Login succeed. What's this warning about? It's an error. No, it's not an error. It's just a warning from Docker about how it stores login credentials. Do I see an error here? A warning. Oh, a password will be stored in unencrypted in here. Okay. Docker keeps the ECR login info on the local machine, so we don't have to authenticate to ECR every time we run an ECR command. It's super convenient, but not the most secure approach. For better security, your credentials should live somewhere safer, like a dedicated credentials manager. If we want to try out AWS credentials manager for ourselves, that's here. Alright, so we need to run the last 2 push commands, which is 3 and 4. So 3 has been run, and 3 was supposed to tag the images, and then 4 is run the command to push the image to the newly created AWS repository. Got it. Alright, done. And it's pushing, and say pushed. And once it's pushed, now we're gonna click close and refresh. There it is. Nice. Now we're going to dive into the backend code. Dun 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 dun. So we're done with the project itself. We're just gonna go to the secret mission. So we're gonna open the GitHub, the backend, and explore the 3 files. Yada yada yada. Take the user inputs. Okay. Open this latest search Hacker News tab, which already has this query. So I think this is the app that a person built. So it's AWS. If we search ARN, we're gonna see stuff about. Oh, we're gonna see stuff about. Okay. I'm supposed to search something else. 1 second. Amazon. We see a lot of stuff about Amazon. Okay. Oh, if we try cloud as well. A lot of different information about cloud. Although we haven't seen the JSON output from our backend since we haven't deployed it yet, we're searching using search Hacker News now. gives us an idea of what type of data the backend will produce. So how does the backend code do all this? Let's find out. Let's open the backend repository, which is here. I think at this point I need to copy and then no, oh shoot, I'll just do this and do this and do this. Okay, so this is it. What's in the repository? There are three main. There's requirements.txt, which has all the dependencies that the app needs. That's Flask, requests, whatever. So, and then to the Docker file, a set of instructions for building. Where are you? Hold the phone. Cool. Anyway, Docker file provides a set of instructions for building the Docker image of the app, and then the app.py is the core of the backend. It contains the actual code that determines what the app does and the kind of responses it sends to the client. Okay, so first we're gonna look at this. It's gonna explain. So Flask is the web framework used to build the backend of the code. There's Flask 2.3.1, 2.1.3, and then Flask REST is the API that creates the extension. The app creates an API extension. The app creates an API using the extension Flask REST so that users and other applications can make requests to our backend. Okay. The requests library is used to get data from Hacker News. Okay. And then WorkZug helps Flask handle application level routing. For example, when a user or service makes a request to our backend, Flask uses its routing system powered by WorkZug to direct the request through the right function in app.python, which then processes the request and responds to it. Now let's select the Docker file. Cool. Okay. So the Docker file defines how the Docker image of the backend should be built. Okay. The steps, this is the contents of the file, how it builds a Docker image step by step. When we talk about the benefits of using container image and containers, such as consistent, reliable deployment across different environments, these commands in the Docker file are exactly what make the magic happen. It installs the necessary dependencies, copies the application code, sets up a command, the command the container needs to run to start the Flask app. Now let's break down the commands in the Docker file. From Python, the first one, from Python 3.9 Alpine, sets up the environment for our app by using Python 3.1 Alpine, which is a very lightweight version of Linux. It helps the app size, keep the app size small, while making it faster to build and run. We're going to use, so now there's label author, next work, adds the author to the metadata of the image. Then there's work directory /app. It sets the /app as the working directory in the container, so the commands in the rest of the Docker file will be run from there. So they'll run from /app directory. Then copy requirements.txt copies the requirements.txt file from the local machine, that's the EC2 instance, into the containers /app directory. So it copies these requirements and then puts them into this directory. That's fair. Then run pip 3 install r requirements.txt installs the dependencies in requirements.txt, and then the copies all the files from the current directory, that is requirements.txt and app.py, into the app/app directory in the container, and then cmd python whatever says the container should run the command python 3 app.py to start the Flask app. Perfect. Now let's select the next one, just app.py. So the first part of it, let's see what's happening in some. Okay, setting up the app.py is the main code for the backend. It has three main parts. Setting up the app and routing. The code starts by importing. Okay, so the first part is for setting up the app and routing. It starts by importing the Flask framework and tools for creating an API. It defines the route, which is /content topics. Where is that? Oh, there it is. So this part, okay. That directs requests to the contents class. This means users visiting the backend will need to visit a URL that ends with /content topics. Is that true? Let's see. I don't see that here, so I'm not sure. This means users visiting the backend will need to visit a URL that ends with /content /the topic to see any result. Oh, /content. Let's see if I see /content. Ah, I see. /cloud. There it is. Because we were searching cloud this time. Let's see. Let's do AWS. Yep. Now it changed. Albeit it's not exactly how we thought it would be directly from here, but it's showing us. Then fetching data. In the content search class, this is the second part. The method extracts the topic from the URL, sends the request to the Hacker News search API to find the release content, and it collects important details like the ID, title, and URL. And then the third part sends the response. The collected data is turned into a JSON format response, a formatted JSON response. What's an API? An API is an application programming interface. It's like a bridge that lets different programs talk to each other. It lets one app ask for data or services from another and gets a response. For example, when a backend runs such a search, runs a search using Hacker News search API, it requests gets data back and processes it to JSON formats to return to the user. This helps different parts of the software to work together easily. In our own backend app, we also create our own API using Flask. This API takes user inputs, connects to Hacker News to get the data, processes the data, then sends it back to us JSON. APIs make it easy for our backend to collect data. Cool. So that was our investigation. So our summary is the app's backend fetches data based on the topic we enter. The backend code uses Flask to connect with the external API, that's Hacker News, and then the backend then sends the data back as a JSON format. Cool. So this is how I process the request. Let's see. Come on. Okay. The backend code creates an API that returns data based on what the user searches for. The user visits the backend's API URL and searches contents AWS. Then why is this thing? Okay. It passes the user's search term into Hacker News API to search. It formats the external API response into JSON, and then it sends the formatted JSON data to the news, and then the user sees a bunch of JSON data on the browser. Okay, cool. Now we're gonna have to delete our stuff. Shoot, I don't know how to do this. Okay. So here's what we're gonna do. Okay. So we didn't use the EKS cluster. Like we didn't use it like we used it previously. So I'll just begin the deletion process. Oh, could not remove cluster. Could not create cluster provider from options. Oh, okay. I need to set the region. I'll do region AF South 1. Okay, cool. So then it's deleting everything that it just built that we didn't use. Cool. This will take a while. Okay. Okay. So we're going to next delete the ECR repository. Also, just in case you're wondering, the other instances were created. These ones, remember the node groups and stuff that we did in our last video? Well, yeah, these are, now we've sent the CLI to delete everything that it already started that already spent so much time creating. I'm going to delete it. To see it, I think we should go to, is it CloudFormation? Yeah, let's go to CloudFormation so we can see it in progress. So you can see deletion in progress. So once this is deleted, then this will start deleting. But it's going to take a while. It takes a long time usually. So we're just not going to wait. So deleted the repository. I'm not going to delete the instance, because if I do delete the instance, then it's going to end this, and then I have to now go back into this side and delete it myself, which is going to be a lot of work and it's a pain in the ass. So I'll just sit down and wait, and you all get to wait with me. So I'll just pause the video. So far, this has taken us about 37 minutes. I think so. It's safe to say that this project took us approximately 40 minutes. Yeah, cool. So in this project, we used Amazon EKS, we used Git, Docker, ECR to repair the backend for the deployment of Kubernetes. Key steps we did was setting up the EKS cluster, cloning the code from GitHub, building and pushing Docker image to Amazon ECR. And then a new thing we learned from experience was that, yeah, now we could open multiple EC2 instances, connect, and tune the structured flow. Yeah, so basically we're doing this project to learn about Kubernetes and Docker. Perfect. Let's see, maybe I should, let's try and generate a new quiz. I may fail, but let's see. What's the primary use of eksctl? Hmm. I think this simplifies EKS cluster creation and management fewer commands. It's a tool. eksctl is a command line tool specifically designed to simplify the creation management of EKS clusters, reducing the number of commands needed. Next, why is Amazon ECR used in this project? To monitor performance, to store backups, to load balance, to securely store and share and deploy. I think that's it. Yeah, because it was supposed to be a storage thing. Yeah. So ECR is a container registry service that securely stores, shares, and deploys container images, making it easy for Kubernetes to access and deploy them. What does a container image contain? Backup an application, like to virtual machine, contains application code, contains all the instructions, code, libraries, and dependencies needed to run the application. Yep, all necessary to run an application, ensuring consistency across different environments. Why is it necessary to create an IAM role for the instance to grant EC2 instance permission to interact with AWS services. Yeah, cool. What does it mean to use to clone a repository from GitHub? Creating a full copy of the code from a remote repository to the local machine. Yeah. What benefit does EKS provide? Amazon EKS only configures security settings. Handles, I think there's a handles Kubernetes setup tasks, simplifying networking, scaling, and security. I think that these answer. Yeah. It automates Kubernetes setup, simplifying networking. Yeah, that's it. Cool, we're done. This is still not done. Let's refresh this. Still in progress. Now it's 41 minutes, so we just have to keep on waiting. In the meantime, mission accomplished. Share documentation. Copy this URL first. Let's download the README file so we can put it on our GitHub. Yes. Then let's go on LinkedIn. Let's do perfect. And see. Okay. Now for you. Oh no. Where's this? This is the project. This is our documentation. Beautiful, isn't it? Perfect, it's all gone. So now if we check our EC2, let me see. The instance still works. Okay. So now if we check here, everything should be terminated. except for the main one. Okay, cool, perfect. So now we can terminate the instance and we're done. First, let me upload this. Choose. There it goes. Commit the changes. And now we have this beautiful project over here as well. Nice. Terminated. So now if we start typing, it's connected. If we refresh, it should still failed. Perfect. There's nothing here, no more private repositories. We're good. Come to the stack and we refresh again. Nothing. It's good. We can't type anything in here anymore. If we refresh, it won't work. Failed. Now let's delete this row. Delete it. And then there are more rules that were created. So I'm just going to look for the ones that were created. 30 minutes, 40 minutes, 29 minutes. So 1, 2, 3. 1, 2, 3. Let's hit delete. It won't delete all of them, but most of them will disappear. So we are done. That was awesome. See ya in the next one.